Hello all, welcome to the day 57 of the daily case study series for CBSE grade 12. The question goes like this. An oil company needs to meet production requirements for 3 grades of oil to satisfy its market demand. The company requires 12,000 barrels of high grade oil, 20,000 barrels of medium grade oil, and 15,000 barrels of low grade oil. So this is the requirement actually. To meet this demand, the company operates 2 refineries, Refinery A and Refinery B. A produces 100 barrels of high grade oil, 300 barrels of medium grade oil, 200 barrels of low grade oil. Operating cost is 400. For B, it produces 200 barrels of high grade oil, 400 barrels of medium grade oil, 100 barrels of low grade oil, and the operating cost is 300. The management wants to determine how many days each refinery should be operated so that the company's production requirements are met at the minimum total operating cost. Based on the above details, answer the following questions. Question 1. Formulate this situation as a linear programming problem defining decision variable, objective function, and constraints. So we have to define the decision variables. Let's take X as number of days refinery A operates and YB the number of days refinery B operates. Now going back to question, for high grade the quantity required is greater than or equal to 12,000. 100X plus 200Y should be greater than or equal to 12,000. For medium grade it is 300X plus 400Y should be greater than or equal to 20,000. For low grade, 200X plus 100Y should be greater than or equal to 15,000. 400X plus 300Y. So this is the total operating cost. Now that we understood the parts of the question, we will define the LPP. Objective is to minimize the total operating cost. Let's name that as Z. So Z is equal to 400X plus 300Y. Subject to constraints, 100X plus 200Y is greater than or equal to 12,000. Next one is 300X plus 400Y is greater than or equal to 20,000. And the third constraint is 200X plus 100Y is greater than or equal to 15,000. X is greater than or equal to 0 and Y is greater than or equal to 0 as they can't be negative. So this is the answer for the question 1. Question 2. Solve for the number of days refinery A and refinery B should be operated to minimize the total cost. Let's convert all the linear inequations to linear equations. 100X plus 200Y is equal to 12,000. Reducing this, we get X plus 2Y is equal to 120. And for X value 0, we get Y as 60. For Y 0, we get X as 120. Second one is 300X plus 400Y is equal to 20,000. On reducing this, we get 3X plus 4Y is equal to 200. For X 0, we get y as 50. For y0, we get x as 66.7. The third one is 200x plus 100y equal to 15,000. Reducing this, we get 2x plus y equal to 150. For x0, we get y as 150, and for y0, we get 75. And the other two are x equal to 0 and y equal to 0. X equal to 0 is the y-axis and y equal to 0 is the x-axis. These lines have to be plotted on the graph. The graph looks like this. The pink shaded region is the feasible region. It is unbounded. The corner points are named as A. A is 0, 150. C is 120, 0. The point B is the intersection of two lines. One is x plus 2y equal to 120, 2x plus y equal to 150. Let's name this as equation 1 and equation 2. Multiplying the first equation by 2, we get 2x plus 4y is equal to 240. On subtracting 2 and 3, we get minus 3y is minus 90 and y is 30. Substituting this y in x plus 2y equal to 120, we get x equal to 60. So the coordinates of B are 60, 30. Now that we have the corner points for the feasible region, we have to figure out the value for Z. The corner points are A 0, 150, B 60, 30, C 120, 0. The value for Z is, for A we get 45,000, for B we get 33,000, for C we get 48,000. So our objective is to minimize the cost. So we choose 33,000, which means Z is minimum at 60, 30. Since we have got a unbounded feasible region, we have to check whether this minimum that we have achieved is a real minimum or not. For that, let's take the objective, which is 400x plus 300y is equal to 33,000. Reducing this, we get 4x plus 3y equal to 330. For x0, we get y as 110, and for y0, we get x as 82.5. Now this line has to be plotted on the same graph. After plotting this line on the graph looks like this, and this is the line that I have marked, the dotted black line. So we have to check whether this line is coming inside the feasible region. Since that line is not in the feasible region, minimum value of Z is that same 33,000 only at 60, 30. The number of days the refinery A should operate is 60, and the number of days B should operate is 30. Question number 3. Compute the Minimum total cost. Total minimum cost is rupees 33,000. Question 4 is provide a brief managerial interpretation of your results. Example, which refinery is more efficient, cost implications, etc. A produces 6,000 barrels of high grade, 18,000 barrels of medium, and 12,000 barrels of low grade. And the operation cost was 400, so 400x, which gives us 24,000. And for B, it produces 6,000 barrels of high grade, 12,000 barrels of medium, 3,000 barrels of low grade. The operation cost is 300y, so we get 9,000. From this, we will try to understand which is efficient in what. Refinery A seems to be expensive because the total operating cost is 24,000. B is less expensive since the total operating cost is only 9,000. Refinery A is more efficient in producing low grade oil and B is more efficient in producing both high and medium grade oil. At a low operating cost. So this is what we understand from the data that we have calculated. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.